Okay, so last lab video, what we did was we combined benzaldehyde with our thiamine HCl with a little bit of base, right? And we discussed the two different methods that we could have done this reaction to make benzoin, but we decided to let that hang out in the drawer for a little bit. We got a little sidetracked with some situations in the lab. Y'all know what I'm talking about, little intruder situation. But I'm back here ready to take a look at the product. I know it's gonna be good, y'all. Let's take a look. All right, y'all, let's check it out. Woo! Oh my goodness, it looks so good. Look at that. Oh my gosh. Shining bright like a diamond. Look at those needles for days. Sorry about. Oh my goodness. Look at that. That's so cool. Crystals, y'all. Crystalline. Alright, so what I'm going to do, technically, we could throw this bad boy in a water bath or an ice bath, but I'm about to throw it in the freezer because, again, I told you about this whole ice bath situation. It's in the ice is in down the hall. I gotta unlock it, and it's just the whole thing. I don't want to waste the ice anyway. I got this beautiful freezer here for chemicals, and I'm also freezing some water, or cooling some water. Sorry, I'm not gonna freeze it. Cooling some water, so that way when I filter it, I can wash it with a little bit of cold water, and it won't dissolve any of those gorgeous crystals. Oh my goodness, are you serious right now? It's gorgeous, beautiful. You're beautiful. What's up? So what we want to do once this is all filtered and stuff. Sorry, I'm doing this while it's cooling in the freezer. We're gonna go ahead and set this to about 100. I don't know how to do this. I'm literally just pressing buttons right now. I forget how it works. I'm gonna hold this menu button down. There we go. Nope, let's click that one. What is that? What are you? 100. Okay, perfect. We want it at 100 because we've got ethanol and water in there, right? So what I want to do is have this oven heat up. We're gonna go ahead and filter our good stuff, our benzoin product, and then we will put it in the oven just for a few minutes to dry, and then we'll get our final mass, and then we can analyze it. Yay! Yay! All right, let's go. Look at this. Oh my! Woo! Look at that. Boom! Look at that. So crystally. This is. Ooh, look at that water. Highly oxygenated and purified for the soul. Got a little Buchner funnel situation. I got that Big Daddy Buchner funnel because, sorry, that probably sounds funny. So my daughter and my son, they call the big animals, that's like the big elephant, little elephant, and then a small elephant is the Big Daddy elephant is the big one, and then the medium-sized one is the mama one, and then the baby elephant is of course the baby. So we've translated that to all objects. So the Big Daddy Hirsch funnel versus maybe the baby, the mama? I don't know. When your world revolves around your kids, you start to adopt their language. So I like it though. So I got that Hirsch funnel. Whoa, did I say Hirsch? Buchner? Buchner funnel. This is the Big Daddy Buchner funnel. Okay, so we got our vacuum going. Boom, you can hear that, I'm sure. What we're gonna do is go ahead and hit that with a little bit of water, just so that we can get, you hear the suction? It sucks the filter paper on there, so that way we don't get any of this, that good stuff creeping, okay? Oh my goodness. You're beautiful. Don't know about James Blunt. crystals are brilliant. My crystals are pure. They look like angels, of that I'm sure. They saw me on a subway. They were with another man. That's not really that my crystals anymore, is it? I'll lose no sleep on that. I've got a plan. I'll filter these crystals. Alright, I lost it. I'm over it. I'm sorry. But basically, I gotta get my spatula and scrape it on. Anyway, we're gonna go ahead and just scrape a day. Get these guys all broken up, kind of. I still like the gorgeous look of it. I don't want to destroy it, but I got it. They're so kind of stuck together. It's kind of like almost like a little slushy in here. Got a little slushy. It's all slushy and stuff. It stinks. It smells real bad. I'm not gonna lie. It smells like poop. Doo-doo. So what that probably is if you remember the structure of the thiamine catalyst. Thiamine has a sulfur atom in there, right? Sulfur compounds usually stink. The sulfur, the reason why skunks smell like boo boo is because they got a thiol, which is a sulfur-containing compound that makes makes it stink. And so, oh my goodness, I might transfer this to the thing. Can't even speak right now. Y'all peep the shirt though? What's up? I wore the benzaldehyde shirt today because I was, I was hoping. I don't remember this smelling so bad, but it does. I didn't remember it. I guess I remember it now. So what I'm gonna do is, what I was saying is that I was hoping that it would smell more like benzaldehyde, but that actually wouldn't be ideal because that would mean that it didn't react. So the reason why I smelled it in the past was probably because the reaction was garbage because it was done the old way and not this good way, that good way. So we are washing with a few pipettes of water. So what I'm going to do is try to rinse out this flask as best I can, but we also don't want our product to dissolve in the water, right? So most of you probably don't even remember James Blunt, huh? He had that one song that one time. It was like the jam. It was probably on every sitcom or something for introduction to Dawson's Creek or something. I don't know. My timing might be off on that. Gilmore Girls, I know they had a revamp of that, so it's probably on there or something. Nobody knows. I don't know where he is now. Y'all see me rinsing this? So I don't know how many times I'm doing this. I'm just doing it whatever I feel. I'm gonna go ahead and smash this. Not smash it, but just kind of spread it around the filter paper. That way, if the vacuum that's kind of sucking this stuff up will actually suck up the solid and the stuff at the top. The better the contact, the better, more efficient this vacuum process will be. So I'm gonna go ahead, probably hit it with a couple more pipettes of water. We've got grams on grams on grams, so we're good. You can see a little bit of solid probably forming at the bottom of this. That's definitely our product, but that's all good because we've got as you know, during a crystallization process, you're gonna lose some of the good stuff, but in the end, you're gonna get something that's a little bit more pure. And so this was kind of like a pseudo crystallization, definitely washing away some of the good stuff while we wash away that bad stuff, because a lot of the liquid in here is going to be that supernatant, And that supernatant contains that stank, that like thiazole. Sorry, that's the ring, 5-membered ring with the nitrogen and the sulfur in it. And it also contains like thiamine catalyst, probably still a little bit of sodium hydroxide or whatever, potassium hydroxide, whatever I use, sodium hydroxide, and that needs to be washed away. So that's what we're doing here. So I'm gonna leave it on here after I rinse it 2 more times with pipette. Leave it on there for 5 minutes, and then I'm gonna put it on the watch glass. I'm gonna pre-weigh that watch glass. I'm gonna put the solid material on that watch glass, throw that right in that oven for 5 minutes maybe, to evaporate any additional water that might be stuck in the lattice structure of this benzoin compound. And then we will weigh it, and then we get to analyze it. Melting point. I think that's all we're doing. I'll think about it. Okay. Bye. Oh, what I wanted to show you is I got all this solid stuck on the spatula. So when I rinse it, I'm just gonna rinse like this. Okay, that way I can maybe get it a little bit off. Didn't get a ton off. Got some of it off. Maybe I'll hit it with one more spatula. Or one more rinsey rinse, cleaning that good stuff. Alright, so that's it. 5 minutes and counting. This is the time passing song. Time is passing, but more time than this. I stole that. Let's go see how much this weighs. Alright, it's already tared. Super cool. Let's go ahead. Record the 53.657 for the watch glass without the solid material on it. So now what we want to do is transfer all this gorgy product to this and throw it in that there oven. Way over there. See that? Ooh. This is like 104 right now. Whatever, we'll see. You spin me right round, Benzo, right round, like a record player, right round, round, round. Let's go put this away. Okay, bye. Alright, so I did set it to 100, y'all saw that, but it's at 102, 103. It was at 104, it's going down because I just opened it, but it doesn't matter as long as it doesn't go above what our melting point is of that product, which should be around 135. Just wanted to show you, this is the Buchner funnel left behind, little some in there, still shining bright like a diamond in there. And then you also got this flask. Looks pretty good. A lot of this here, oh, you can't see that. That's condensation because it's evaporative cooling, but you can definitely see some solid in there. There's a significant amount in there. All good though. It's time. Let's take a look. See. So, remember that time when it was 100 degrees? So like touching it might be real hot, but you know how I do. Go ahead, place that right here for a minute. And then we'll go ahead and let that cool to room temperature before we weigh it, okay? Well, here we go. Let's go ahead and weigh this. What we want to do is just find the difference between the mass of the watch glass and the mass of the watch glass plus the product. That would be the product mass, right? And 61.268 grams now. So go ahead and record that. Now what I want to do is, you probably saw at the beginning of the video. So what we're going to do next is put a little bit of this in a mortar and pestle, or let's see, in the mortar, and then crush it up, and then put it inside of the melting point tube. So you saw how beautiful these crystals were. They are nice and shiny, but they aren't going to form like a compact like powder on the bottom, so that's why we want to grind it up. so that way we don't have any air space inside of our melting points tube when we are analyzing it, and that way we get a nice number. So yeah, we'll see what it looks like. I also already got the melting point apparatus preheating to 30 degrees, roughly 30 degrees below where I think it's going to melt. So I just put it at 105 because I think 135. Might be a little bit below that though. We'll see. The aftermath, that's looking nice and powdery. It's also going to be a lot easier to get this solid material inside of my capillary too. Give a little tap, tap, taparoo. Oh my goodness. I'll be sure to clean that up before I leave. But there you go. What's up? Still looking pretty. Oh, it looks kind of gross in the camera. Gotta get that right angle, right? I guess even solid material or like solid chemicals need the right lighting to look pretty, huh? Not just people on the Instagram. There you go. I'm just speaking nonsense right now, yo. All right. Okay, so we got it at 105 already. We're gonna go ahead and hit start. Let's see, the light went from, it was preheat, then it went to ready, it was green, and then it's at melt now. So we shall take a look-see. Can't zoom on that fast motion. Yeah? Can you come in here, please? In the analytical room. I'm actually recording a video. I'm gonna say hi to my students. 1:30, 1:06. Can you come grab it out of my pocket? Please. Please. No! Shit. 1:33. God. The worst. My wife accidentally called me in the middle of this video, and so 1:35 exactly, and that's it was right at the end when it was melting. So but I think we got it. Yeah, it's all good. That was pretty good though. My wife, man, whoa, she's goofy. Okay, so I think we got our numbers though, so like we're cool. It happens, unfortunately, kind of a lot. What we're gonna do right here is get a little something, a little solid material in here. Y'all remember what's in this? Yeah, do ya? It's a desiccator because we want to keep these things dry. These salt plates right here, remember? These are for the liquid IR. But what we're gonna do is actually dissolve a little bit of our benzoin, inside of this tube with a little bit of methylene chloride. And then we're gonna take this guy right here and go bloop bloop on here. Let the methylene chloride, bloop bloop means drop some of that methylene chloride benzoin solution onto here, and then it'll dry because methylene chloride's just super volatile, right? Warm hug. Once it leaves, it'll leave a thin layer of that solid material. So this is called like a dry film, and that's another way to do an IR. And you can't do it with everything though. You can try. It's pretty easy. So that's what we're gonna do. Check it out. Need a lot, right? We're just doing a little tiny bit on our for our IR. We shall see. I'll bring you with me. Hey, how you doing? All right, good. I'm glad. Let's do this. Okay. All right, we got methylene chloride, of course, in the hood. This one a little lower. and then let it dry or evaporate, and then we'll take a look at the film. Kind of see something. Let's just try it. So Toads thought I was recording this, but it wasn't. Anyway, I ran the sample. That's neat. So what I did find is that just as a reminder, we pressed it on this little thing right here, and we did get kind of what we were expecting, just not very pretty. So there's a little carbonyl stretch right here. There's a little OH stretch right there. Okay. Then there's like boom. Okay, over there. Maybe we'll do it again, and then we'll let it dry for a minute, or like dry longer. But it will also have more sample on there. All right. One thing I wanted to show you was, all right. So I got this guy right here. Got a peak here. Right here and here. Notice the difference at this 1670 whatever peak. When I have my other sample, it gets a lot smaller, right? So this is the first one we did. It's not bad. Then I added more sample and it got smaller, and then I just got a better one. Okay, so what I did was I actually offset this salt plate, so that way you might not be able to see it, but the center, so this hole in the back, that's where the IR light shines through. It actually goes through more of what I perceive to be the sample. And so just by doing that, I ended up getting a better IR. And it looked like that. So there you go. Just another kind of tip, I guess. Okay, well, it's super annoying. I can't get the image to rotate. I'm doing this on my iPad and basically I just wanted to talk to you about the spectrum a little bit. More so just show you that I have it. I'll give you the PDF of it, so no need to worry about that. You don't need to use this to analyze your spectra, but I guess I just wanted to have something on the screen while I talk to you. Just some last minute things. Basically, this is the first step of our multi-step synthesis. So we created benzoin, and now what we're going to do next week is take the benzoin that we made, and we're going to make something new out of it, benzyl. Okay, so stay tuned for that lab video, but that's the idea of a multi-step synthesis, right? We always draw things on paper, right? So you can take an alkyl halide and you make it into an alcohol or whatever, and then you can do it whatever. I mean, Diels-Alder with it or something like. That's the idea of a multi-step synthesis. Is you can make something, kind of isolate it, and then analyze it, make sure you made the right thing, and then once you've shown that you have made the right thing, you can use that to make another thing, and then another thing, and then another thing. And so this is a 4-step multi-step synthesis process, and that was the end of step 1. And so what you should do is analyze the IR data compared to literature values, analyze the melting point data compared to literature as well, and then of course if you had any physical descriptions of that solid material, see if our crystals match it. It was like a nice white, almost like a glass for some of the crystals, with a hint of yellow, which you might assume that yellow material is from the supernatant, right? And maybe we didn't wash it well enough. We could crystallize it. We may or may not by the time we do that next reaction, but for now, that's our yield. Analyze the yield, and you got a lot to talk about. You have a lot to talk about in terms of errors on this lab and reasons why we might lose material. So make sure that you're literally getting all of them, because we're going to be looking really well at the sources of errors for this lab, because there's a ton. So from both videos I mentioned quite a few, and you should talk about those. All right, so hope you had fun. I did. I'm ready to get a bear claw and a coffee, y'all. What's up?